So now I'd like to focus all of our efforts on the reflection transformation. Okay, and we're going to take as our object this time a point in two-dimensional space. So just a point, and we're going to see how it transforms under reflection. Okay, so the first possibility that I could do is something called the identity transformation. The identity transformation is the do-nothing transformation. Okay, it sounds trivial, but it's very important. I'm going to call it I for identity. Okay, that means you take the point 2, 1, which is the point I'm choosing. It's just any point you could choose. So take the point 2, 1 and do nothing to it. So that looks like this. The point 2, 1 gets transformed to the point 2, 1. Okay, now what happens if I take the point 2, 1 and instead of the identity transformation, I reflect in the x-axis? Okay, what does that mean? Well, we're using the x-axis as the axis of reflection, so I come down to the x-axis and then I go the same distance the other side. So my point 2, 1 under reflection in the x-axis, my point 2, 1 gets transformed to the point not 2, 1, but 2, minus 1. Okay, it drops down beneath the y-axis. Right, what about reflection in the y-axis? If I take my point 2, 1 here, and now I reflect it in the y-axis, so I walk it across to the y-axis, then I walk the same distance again. In this case, the point 2, 1 gets transformed over here to the point minus 2, 1. So it's in the negative x direction, but still in the positive y direction. Okay? And the last possibility, we'll call this RF0. This is reflection in the origin. So I take my point 2, 1 and I walk it over to the origin. And then I walk at the same distance the other side. Okay, so in this instance, the point 2, 1 gets transformed to the point minus 2, minus 1. Okay, it's underneath the y-axis and cross over in the negative x. Okay, so in this instance I chose the point 2, 1 as our beginning point. But I didn't have to do that. I could have chosen any point. So to make this more abstract, I'm going to write the rule based on any arbitrary a and b. Okay, so instead of 2 and 1, we're talking about a, b. Okay, but a, b under an identity transformation remains a, b. Okay. Under a reflection in the x-axis, a, b, looking at our result here, would become a minus b. Okay? Then under a reflection in the y, any point a, b would become minus a, b. And our arbitrary point a, b, if transformed under a reflection in the origin, will become minus a, minus b. Okay? What's interesting to note, though, is that if I begin with my point 2, 1, and I reflect that point 2, 1 in the x-axis, and then reflect that point in the y-axis, I arrive at the same point as if I had just done a reflection in the origin. Okay, so it's interesting to start to think about combinations of transformations. So if, for example, you do a reflection in the x-axis and then do an identity transformation, well, that's the same thing as just doing a reflection in the x-axis. But what if you do a reflection in the origin, and then you do a reflection in the x-axis? Well, that gets you to the same point as just doing, from the beginning, a reflection in the y-axis. Okay, so it's interesting to start to think about combinations of these transformations, and that's what we'll talk about in the next video.